Hey guys, this is Frank, and I'm here to talk about pointers in C. You guys are probably here because you quite not get the idea of it, and that's okay because a lot of people don't get them this first time around. They're a very tricky thing because beginner programmers don't understand what memory is and stuff like that. So it makes sense for you to be actually looking for a YouTube video because a lot of people just want to see visual representation of the tutorial anyways. So I'm just going to dive right into it. So let's start with the basic skeleton of a C program. And yeah, so you got that. That's a basic skeleton structure of a C program. You have your main. So what a pointer is, it's a variable that holds an address to another variable. So that's an easy concept to hear, to read, but a lot of people just don't understand that just because you're like, why the hell do I need that? Well, you're gonna need it because a lot of people don't like global variables, and if you're used to using global variables, making your little calculators for your friend to see, and trying to make some thing says you're cool when you type in your name, or just when you start up the program just to make yourself feel better in the morning. That's not anything fun. That's just boring shit. So let's talk about pointers because pointers are where it's at when it comes to C and C++, and that's one of the reasons why there's still a lot of tutorials about it, and I'm even jumping on behind that because they're really important. Alright, so let's start up with the very basic integer variable. I'm just going to do int a equals 15, and that's it. So you got your basic integer variable there. It's fine. It has the value 15. Nice. So let's make a pointer of an integer to hold this variable in it. So, okay, so we got int asterisk. An asterisk declares a pointer. So you can actually have any other type of variable type here inside a C. So that's cool. And the star is always going to be the star, and it's always for declaring a new pointer. And we're going to do ptr equals, and the reason why I use ptr is just for example purposes, not anything special. I can do a pointer or my face or your mother. So, simple shit like that. But for this, I'm just going to do pointer. Cool. A. Bam. That's all it took. Now we hold the address of A. But wait, you didn't talk about what that ampersand is. What the hell is that? I've seen that before because I've read it. Well, ampersand, that little backwards 8, is actually what grabs the address out of the integer A, which is really important in C because you need to know the address to actually work with a regular variable within a pointer. So that's good. So you're understanding something. An address is grabbed by an ampersand. Awesome. So if we were to print this out, which a lot of you probably already did, and you're like, oh, I know I can print this out, it's just a basic integer. Well, it's not. So if you try something like this, like any other noob that's out there, and I'm not trying to be mean or anything, but I did this too, shit, and I got made fun of because it was just bad shit, man. So if you try doing this, you're an idiot because that's not how it works. It seems simple, but let me show you what happens here. I'm gonna compile. It's gonna give you a warning first of all, saying that the format is not an int, and the variable that you're giving is not an int. It's actually an int, a star, or an int point, or a pointer of an int pointer. So, it's gonna give you some shit there, and then you're gonna be like, oh, whatever. It's just a warning. So my program's still compiled, and you compile it, and you get 16 blah blah blah. Holy shit! What just happened? Well, what happened was you actually printed out the address of 8. So you're getting there, but you're not just there. So there's this thing called dereferencing, and dereferencing is really important because what it does is it gives you the value of where of what the address holds at that, or the value of what the address holds at that point in the memory. So just dereferencing it, I'm sure you've heard it, is not actually telling the pointer to get rid of the value or anything like that, because dereferencing sounds like you're getting rid of. I don't know. For me, it did. That's where I'm trying to come from. So that's not what it means. It just means I need you to give me the value that you're pointing to, or not the value you're pointing to, but what the address holds at that point. So to do this, all you do is a simple asterisk before the pointer name. So that's simple enough. You can even go along the lines to saying that the declaration of pointer to to get the value of the address, or what's held at the address, they're pretty much the same. So that's pretty good to know in terms of tests. If you're trying to, bone up on a test right now, that's good because you can keep some similarities there. They're going to look the exact same for that. So at this point, you can actually compile this, and it should give you 15, which is the exact same number that we have A equal to. Whoop-de-doo. So awesome. Let's see. Now let's look at the address, which is given to us by just doing the pointer. But instead of just printing out the number, I'm going to get the hexadecimal of what it actually looks like in a hexadecimal format. So we're going to use the format P, which in printf you can look up the formats, and Google, do all that, is do printf formats in C. Big deal. And it should give you this P, and what that does is the pointer address, so it'll fix it up just for you. So we compile this and then we print it. Now we got a nice little hexadecimal version of that large number that we had before. So that's what that number would equal in hexadecimal. That's cool, because that will give you some idea of how to do some debugging if you ever need to make sure you're passing around the right address to the variable and stuff. So that's nice and all, but I'm sure you're wondering, what the hell can you do with these? Alright, so let's do an add function, and we'll make an int pointer as an argument, and we'll call it pint. And this is just a prototype, so we're going to declare it down here. That way we can use it inside the main without having to declare the whole function up here. If you guys didn't know that, well, shit. So here we're going to declare it, and now we have pint. Alright, so what we're going to do with pint is we're going to dereference it at the beginning, which would allow us to set the value that the address holds in memory. So that's cool. So not only can you output it, but you can also set it at the same time. So that's really cool. So let's see. Now we want to do equals and then the value plus 5. So this should give us 20 if we're to, or whatever number you have, A plus 5. Okay, so we're going to do an add and A. Wrong. That's not what you do. Or let's pass it in that way. No, wrong. That's not how it works. You just do a simple pointer to pointer passing. So a pointer holds an address, and if the argument's a pointer, you can pass addresses, just like you would pass 15 to a regular int b, just like that. So that's along the lines how that theory or logic goes. Is their exact same variable or they hold the exact same type of variable, so you can just pass it on through. So now in here, pint would equal a, because we just told it to add with the function argument ptr. So in essence you would have here ptr, and in here you would have ptr. So you switch those out, and that's the type of idea you'll be getting, or the type of arithmetic you'll be getting at this point. So that's cool. So let's test this out. Alright, so you got 20. Cool. And if you notice, the address didn't change. Awesome. Don't you feel special? You can show this to your buddies. That way you can have some friends. No bullshit. They'll just look at you like you're stupid. Because you're smart, you're programming, you're learning. Alright, so add. That's cool and all. But what if I just want to add 5 to the regular integer a? Can't I just do that with this function too? Well, actually you can. So how you do that? Same way that you declared the pointer right there. You're basically just in the sense of declaration, you're just doing this. So before you're doing PTR, so now you're doing this whole little deal. So now you want to send an A. Well, A can't be passed in that way because over here we used an ampersand. So we need to set an ampersand here with A. That way it passes in the address of A. So when you pass it over here, you'll notice a similarity from this declaration to this declaration. And that's how it works. That's the idea behind that. So if you ever seen those ampersand within a function call with pointers, that's why they do that, because the idea is just like that. So let's compile this and let's print it out. And look at that. We added 5 to A without even creating a pointer. So that's awesome too, because you can cut out the bullshit and not even worry about returning variables anymore, because you're working with fucking pointers. You can feel fucking special. See, that's all it took. I don't even need pointers anymore to be declared for basic variables like this. All you have to do is pass the address in. So now you're thinking, that's cool, it's so cool. But what else can you do with them? Well, there's a lot more you can do with them actually. But, you know, let's just keep it simple for now. This is pretty damn good that you've followed me so long in this video. So, you know, congratulations. I don't got a diploma for you or a hug, but, you know, thanks for watching. Alright guys, take it easy.